Welcome back, guys. Today's video is on highest common factor using the factor method. Let's get right into it. To find the highest common factor using a method that I like to call the factor method, and some of my students like to call the shortcut method, we are going to use a method that is similar to when you have to find the LCM using the factor method. Now, even though I teach this method to my students, I usually don't encourage them to use it, and I'll tell you why before the end of the video. Now let's get right to it. Using our first example here, find the HCF of the following numbers. We have 16 and 28. So just like we do when we are finding LCM using the factor method, we're going to write the numbers out like this. And you're going to be dividing them, but you will use only factors that are common to both numbers. In LCM, you can use any factor, even if it's not a factor of the both numbers. But in this case, the factor you will use to perform the division must be a factor of both numbers if you are giving two numbers, or all three numbers when you are giving three numbers. So the first factor that is common between 16 and 28 is 2. 16 divided by 2 will give us 8. And 28 divided by 2 will give us 14. Now, between 8 and 14, the next factor common between them is 2 again. 8 divided by 2 will give us 4. And 14 divided by 2 will give us 7. Now, you look at 4 and 7, there's no more common factor between them, which means we have come to the end of this division. Now, when you're using this method for LCM, you only stop when you have arrived at 1 and 1, but you don't do that for HCF. You don't have to get to 1 and 1. The moment there's no more common factor between the numbers, you have come to the end of the division. And to get the HCF, we're just going to multiply the factors we use to divide. So in this case, we're going to say, so therefore, HCF is equals to 2 times 2, and our HCF is going to be equals to 4. So that's it on this method. Is simple, it's short, and it's precise. Let's go ahead and take a look at another example using this method. So we have find HCF of the following numbers. We have 81, 108, and 135. So let's go ahead and write them out just like we did in the previous examples. We have 81, we have 108, and 135. Now the first factor that is common between all three numbers will be 3. 81 divided by 3 will give us 27. 108 divided by 3 will give us 36. And 135 divided by 3 will give us 45. Now, like I always say, if you can't do the division offhand, like I've just done, it's okay to take a rough paper or just come to the side and break down this division the way you're comfortable doing it, so that it's so you get the correct answer, because the most important thing is that you get the correct answer. So if you do this, you can break it down. 10 divided by 3, and you're going to get 3 remainder 1, and 18 divided by 3 will give you 6. So that's how we've arrived at the 36 we have here. You can do the same for 135. 13 divided by 3 will be 4, remainder 1. 15 divided by 3 will give you 5, and you have 45. So let's go on with our division between 27, 36, and 45. The next common factor between them will be 3 again. 27 divided by 3 will give you 9. 36 divided by 3 will give you 12. And 45 divided by 3 will be 15. We look at 9, 12, and 15. And the next factor is going to be 3. 9 divided by 3 will give you 3. 12 divided by 3 will give you 4. And 15 divided by 3 will give you 5. Now when you look at 3, 4, and 5, there's no common factor between them. So you know you've come to the end of your division. And very quickly, let me just say the reason I don't usually encourage this method for my student is that there are instances where you can assume that you have used all the common factors even though you haven't. Say for example, after this first two divisions you arrive at 9, 12, and 15, and then you forget that 3 is common between 9, 12, and 15, and you decide to stop after the first two divisions. Of course your answer is going to be wrong. So that's the reason why I usually don't encourage this method. So if you're going to use this method, be careful and make sure that you use all the common factors to perform your division before you stop. So let's go ahead and finish up here by saying, so therefore our HCF is equals to 3 times 3 times 3. 3 times 3 is 9, and 9 times 3 will be 27. So that's the HCF of 81, 108, and 135. So one last example on HCF using this method. We have find HCF of the following numbers 30 and 45. And of course, we're going to go about it the same way. We're going to write 30 and 45. And the first common factor between them will be 3. 30 divided by 3 gives us 10. And 45 divided by 3 gives us 15. You look at 10 and 15, and the next common factor between them will be 5. Notice that I'm not going to use 3 because 3 is a factor of 15, but 3 is not a factor of 10. So it's 5. I'll use 5. And then 10 divided by 5 will give us 2. 15 divided by 5 will give us 3. Now between 2 and 3, there's no more common factor. So we'll stop at this point. Now we're going to say, so therefore, our HCF will be equals to 3 times 5. And 3 times 5 will give us 15. It means that the highest common factor between 30 and 45 is 15. So that's it for this lesson. Guys, if you enjoyed it, please do to check out the next video on the differences between factors and multiples, as well as the difference between the highest common factor and the lowest common multiple. As always, I've got a bit of classwork here for you to try. Find the highest common factors of the following numbers and do to try them in your free time. And if you want them to be evaluated, you can send them to the email on your screen, mathswithmrspeace@gmail.com. I'll be happy to go over them and send you feedback where necessary. So that's it for this video, guys. Thank you for watching. Please do to like, share, subscribe, and turn on our notification button so you will know when we've uploaded a new video. I'll see you in the next one. Bye.